Hello friends, today we are going to study about covalent bonds. What are covalent bonds? Covalent bonds are the bonds that are formed due to sharing of electrons. Here the example is given of oxygen molecule which is formed due to sharing of two pairs of electrons between two oxygen atoms. The atomic number of oxygen is 8. That means the electron distribution is 2 and 6. 2 in K shell, 6 in L shell. How many electrons L shell can hold? Total 8 electrons. This we already studied in previous videos. Those who have not seen the videos, I have provided the link at the end of this video. So it needs 2 more electrons to become stable. Same with the case of this oxygen atom. Both the oxygen atom needs 2 more electrons to become stable. So what they are doing? They are sharing 2 pairs of electrons to become stable. So for this first oxygen atoms, now the number of electrons or the valence electron become 1, 2, 3, 4, 5, 6, 7 and 8. Similarly for this oxygen atom also 1, 2, 3, 4, 5, 6, 7 and 8. Correct? So both the oxygen atom share two pair of electrons. They became octet stable and formed oxygen molecule. Now, what is the difference between ionic bond and covalent bond? Why oxygen molecule is formed due to covalent bond, not ionic bond? And why NaCl form ionic bond and not covalent bond? So one reason is difference in electronegativity among atoms involved in bond formation. In case of NaCl, atomic number of Na is 11. Atomic number of chlorine is 17. We already learned that in a periodic table, when we move from left to right, electronegativity increases. So chlorine is much more electronegative as compared to sodium. Therefore, it can take electron from sodium. It can snatch electron from sodium. So hence, chlorine can take electron and sodium can donate electron. In case of oxygen molecule, both the atoms involved are oxygen. So the difference in electronegativity is absent. Clear? So covalent bonds are the bond which are formed when the involving atoms have negligible or no electronegative difference. Correct? So now the difference between ionic bond and covalent bonds. Ionic bond formed because of transfer of electron. Covalent bond forms because of sharing of electrons. In case of ionic bond, the atoms involved should be differ in electronegative property, whereas covalent bonds are the bonds where atoms do not differ in their electronegative property. Ionic bonds are less frequent in biological system, whereas covalent bonds are more frequent in biological system. Bond length. For a perfect bonding, the distance between two atoms involved in bond formation is very important. Here the example is given of hydrogen atom. When the distance between two hydrogen atom is 300 pm, we can say no attraction among two atoms, so they cannot form bond. When the distance is 74 pm, that is the perfect distance when a perfect bonding can happen. So the distance between two atoms, or we can say the internuclear distance, is very important for perfect bonding. If the distance is too far from each other, then they cannot form bond. When the distance is too less, here R is 45. Here also they will repulse then. Why? Because this is one hydrogen atom, this is another hydrogen atom. When they are so close that both the nucleus overlaps each other, the nucleus is positively charged, so positive will repel each other. So the perfect bonding is not possible. So for perfect bonding, the bond length or the internuclear distance is very important. Too far cannot form bond, too close cannot form bond. An optimum bond length or an optimum distance between two atoms is very important for a perfect strong covalent bond. Single bond, double bond and triple bond. This we already studied in previous videos. Those who have not seen the videos, I have provided the link at the end of this video. When there is one electron sharing, it is single bond. The orbital involves is s orbital. The bond is known as sigma bond. As we already studied, s orbital is circular in shape, small in size. So they get more surface area for interaction. So sigma bond is always stronger compared to the pi bond, which is formed due to the overlapping of p orbitals. In case of double bond, two electron sharing occurs. One involves s orbital, another involves p orbital. The bond formed due to s orbital is called sigma bond. The bond formed due to p orbital is known as pi bond. In case of pi bond, the bond formation occurs by the interaction of only sideways. So they get very less surface area. Hence, pi bond is weaker as compared to the sigma bond. Coming to triple bond, where three electron sharing occurs, one s orbital involves and two p orbital involves. So one sigma bond and two pi bond. Clear? Sigma bond is formed due to s orbital overlapping. S orbital is circular in shape, so they get more surface area. So the bond is stronger compared to the pi bond. As because it is small in size, so steric hindrance won't be there. So the bond formed due to s orbital will be flexible in nature. Now here the points are given. Bond energy. Triple bond is stronger than double bond is stronger than single bond. Correct? What we studied is sigma bond is stronger compared to pi bond. In case of one electron sharing, the bond involved is sigma. For example, energy is X. In case of double bond, one bond in sigma, it will be X plus. For pi, it won't be X. Why? Because pi is not as strong as X. So it will be less than X only. But definitely some value. For example, take it Y. Correct. The energy of Y is less than X. Because pi bond is weaker than sigma bond. So in case of double bond, X will be there because of sigma, and Y, which is, though it is less than X, but it will give some input in energy. Clear? So double bond is stronger than single bond, but the value is not double. The energy is not doubled. In case of triple bond, X plus Y plus Y. So it is again stronger than double bond, but it is not the case that the amount of energy is just doubled. Clear? So single bond is weaker compared to double bond. Double bond is weaker compared to triple bond. Clear? But sigma bond is stronger than pi bond. Clear? So bond energy increases from single to triple bond. Coming to bond length decreases from single to triple bond. Bond strength, again it increases from single to triple bond. Reactivity, again it increases from single to triple bond. Rotation, it decreases from single to triple bond. Why? Because single bond involve s orbital. S orbital is circular. It won't create any steric hindrance. It will be flexible in nature. So it can rotate, twist and turn, which we already studied in the previous video. Correct? Here again the same thing, sigma and pi bond. Sigma bond is more stable bond because head-to-head overlapping occurs, and it also allows rotation. In case of pi bond, it is weaker bond because sideways overlapping occurs and it restricts rotation. Now come to polar and non-polar covalent bond. Here three examples are given: water, methane and carbon dioxide. Now in case of water, the elements involved are oxygen and hydrogen. Oxygen is much more electronegative, therefore it attracts the shared pair of electron towards itself, hence it gains partial negative charge, whereas hydrogen gains partial positive charge. Clear? Therefore it is polar in nature. In case of methane, carbon and hydrogen have almost equal electronegative character. Therefore it is non-polar in nature. In case of carbon dioxide, again, oxygen is more electronegative than carbon, but still it is non-polar in nature because bond angle is 180 degree. To know whether the covalent bond is polar and non-polar, one thing we need to say is the shape, molecular shape. It needs to have some angle to be polar natured. If the angle is 180 degree, it will become non-polar. Correct? And another thing is the electronegative difference. If the difference is less, then it will remain nonpolar in nature. Correct? Now the shape. What is the importance? It's like a tug of war. One person standing here, one person standing here. If both the person have equal strength, then this rope will remain in the center because both the strength will cancel out each other, which is happening with CO2, carbon dioxide. One atom here, one atom just opposite, 180 degree. So both the strengths are cancelling out each other. Hence, carbon dioxide is non-polar in nature. Now, there are few things to know that whether a molecule is formed due to ionic bonds or covalent bonds. If covalent bond, whether polar or non-polar. The first thing, which we already studied, electronegative difference should be there. Ionic bond formed due to atoms which are different electronegativity. In covalent bond, the electronegativity is either absent or very negligible. But it is not always the case every time. For example, water. Atoms involved are oxygen and hydrogen. Oxygen is much more electronegative than hydrogen. Then why this compound is not formed due to ionic bonds? Why covalent bond? How many electrons hydrogen has? 1. So it cannot donate that electron, right? Because if hydrogen donates 1 electron, it cannot exist because it has only 1 electron. If it donates that electron, it cannot exist. So it cannot donate that electron. And because oxygen is much more electronegative compared to hydrogen, it cannot take electron from oxygen. So hydrogen cannot donate also, and it cannot take electron from oxygen also. That's why they are involved in the covalent bond formation. Clear? Now come to the example of carbon dioxide. Here carbon and oxygen are involved. Here also there is a difference in electronegativity. Oxygen is much more electronegative as compared to carbon. But because the bond angle is 180 degree, they cancels out each other and hence it is non-polar in nature. So what is the importance of shape? We already studied if the angle is 180 degree, they cancel out each other and the compound will be non-polar in nature. If they have some angle, the compound will have the polar nature. Now, though they have angles, then also there are few things on which the polarity or non-polarity depends. Here the example is given of CCl4. Suppose you don't know the shape also. How will you tell that this is a covalent bond and next that this is a non-polar covalent bond? Correct? First thing is the involvement of carbon. Carbon cannot form ionic bonds. Why? Because carbon has 6 electrons. 2 and 4. Valence electrons are 4. So to become stable, either it can take 4 electron or it can donate 4 electrons if it has to form the ionic bond. Now if it takes 4 electrons, then after adding 4, how many electrons it will become? Plus 4. So now 8. 8 plus 2, 10. Or 6 plus 4, 10. If it takes 4 electrons, how many electrons it will have then? 10. How many protons carbon have? 6. Because its atomic number is 6. 6 proton cannot handle 10 electrons. The atom will become unstable. If it donates 4 protons, then how many electrons it will left with? 2 electrons. 6 protons cannot handle 2 electrons also. It will again become unstable. So carbon can never form ionic bond. It has to form covalent bond only because neither it can take electron nor it can donate electrons. Correct? So from here, we can say that CCl4 is a covalent compound. Now, it is polar or non-polar. If we don't know the shape, that it is tetrahedral in nature, how can we say that it is a polar or non-polar in nature? Carbon. Valence electrons are 4. In case of CCl4, what it is doing? From 1 Cl, 1 electron, 1 Cl, another electron, again 1 Cl, again 1 Cl. This is carbon. So 4 electrons carbon and 1 from each Cl, it became octet. 8. 4 plus 4, 8. Okay. Now you write 8. Here Cl also sharing 1 electron with the carbon. So this one pair of electron they are sharing, -2. Here also one pair of electrons, -2. Here also one pair of electrons, -2. Here also one pair of electron, -2. So 8 minus 8, 0. Hence CCl4 is non-polar compound, non-polar covalent compound. What is happening here? Carbon has 4 valence electrons. It is sharing one pair of electron from one chlorine, again one pair of electron from second chlorine, again one pair of electron from third chlorine, again one pair of electron from fourth chlorine. Hence CCl4, 4 chlorines are involved. Clear? It became octet, 8. Now you have to write 8. Now minus. So this chlorine shares one pair of electron. So 2 electrons. Second chlorine, again one pair of electron. Third chlorine, again one pair of electron. Fourth chlorine, again one pair of electron. Clear? So they are sharing this 8 electron. Clear? Which cancels out and it became 0. Now come to NH3. NH3. Atomic number of N is 7. So electron distribution is 2 and 5. Valence electron, 5 valence electron. Now, for 5 valence electron, 1, 2, and 3, 5, 6, 7, 8. Octet. One pair hydrogen with hydrogen, one pair with second hydrogen, one pair with third hydrogen. Became octet. 8. Okay. Now what you have to do? Write 8 minus one pair of electron, 2. Second pair of electron, 2. Third pair of electron, 2. So 8 minus 6, 2. It left with 2 electrons. Hence, NH3 is a polar covalent. If you see in any book or anywhere, you'll find the structure of NH3 as like this. Okay, hence NH3 is a polar covalent. So you can calculate like this and you can find out whether the molecule formed due to polar or non-polar covalent bond. Clear? Next is dipole moment. It expresses the degree of polarity. The formula is mu equals to E into D. E is the product of electric charge and D is the distance between positive and negative center. It expresses the degree of polarity, means it will tell how much a molecule is polar in nature. Now come to bond strength. As I told you, single bond is weaker compared to double bond. Double bond is weaker compared to triple bond. Correct? But because in single bond, sigma bond is involved, s orbital. So it is more stable or it has more energy compared to p orbital or pi bond. Correct? Single bond is weaker compared to double bond. It is weaker compared to triple bond. But what I said earlier is it is not like that. The energy, if it has X, it will become 2X. Correct? Now you see here. Carbon-carbon, single bond. The energy is 350 kilojoule per mole. Double bond. The energy is 611. If it gets doubled, then what would have this energy? 700. But it is lesser than 700. Why? Because pi bond or the bond involving p orbital is not strong or stable compared to sigma bond or bond involving s orbital. Similarly, C triple bond C. The energy is 816. Correct? So, single bond, double bond, and triple bond. In case of energy, it increases as we go from single to triple bond. Correct? But energy does not doubles. Okay? Now, one more thing to notice is if the atoms involved are smaller, like here Cc, here H. Hydrogen atom is smaller than carbon atom, the energy is more. It is 436, here carbon, it is 350. So smaller the atom, greater the energy. Correct? Another thing to note down is if the atom has similar size, then polar covalent bond will have more energy compared to a non-polar covalent bond. Correct? Why? Because in case of polar covalent bond, along with having the covalent nature, it is also having an ionic character. Because polar means in case of water, no, it H has partial positive and oxygen has partial negative charge. So along with having this covalent bond strength or property, it is also having a slight of ionic character. So always polar covalent bond has more energy compared to a non-polar covalent bond. Now you have to tell me whether methane is a polar or a non-polar covalent compound. Write in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.